Hello students, once again welcome back to Misostudy video classes. And as you know from this first slide, it is clear that today we are going to discuss CBSE pattern question exercise, and that too for chapter number 14, that is semiconductors. Fine. So, the same process we are going to follow in this particular explanation also. Questions classified in 1 mark, 2 mark, 3 mark, 4, 5 marks, like that, short, very short, long answer type, and then I will explain you the solution of these questions. So, here the most important aspect is this thing. If you try to recall, in each of my PPTs, I always mention that first read the instructions carefully. Fine. So, the first question is for 1 mark, that comes now already on your computer screen, that is, what is Fermi energy? Now, why I picked this question? Actually, it is a very abstract type of question. What is Fermi energy? So, the answer once given by one of my student was, sir, energy associated with Fermi level is Fermi energy. Very good, very clever answer. But suddenly one student raised the doubt, what is Fermi level basically? I thought the answer is complete in itself, energy associated with Fermi level is Fermi energy. But yes, then this question may come in mind, what is Fermi level itself? So, I thought let us pick this question, and with the help of this question I will define basically these two things. Fine. So, the first answer, the simple answer for this particular question is energy associated with Fermi level is defined as Fermi energy. And for ensuring perfect marking even in 1 mark question, or to give the impression to the teacher, the examiner, the evaluator, that you are well prepared for this topic, you should also mention that the highest energy level occupied by electrons at 0 Kelvin is known as Fermi level, and the energy associated with this level is defined as Fermi energy. So, now even I with the help of this one question, basically I told two questions. One is what is Fermi, let us say someone is asking what is Fermi level. So, you can write down the highest energy level occupied by electron at 0 Kelvin is known as Fermi level, and energy associated with this level is defined as Fermi energy. Simple. So, now the answer is complete, and also you learn one more question. So, it is like that it was an offer, 1 and 1 free, ask one question, get one more answer free. Fine. After this it comes question number 2, and please do not forget that this 1 mark scheme is applicable for both 1 and 2. Okay. That is out of electron and hole, and this question is true only with reference to semiconductors. Out of electron and hole, which one has higher mobility? Now, why this question came in my mind? When I was explaining once, it was few years back, I was explaining this PN diode. So, I said mobility of this electron and holes, like that. So, one of the student asked this question, which one moves faster? Fine. So, the answer, because of that particular question, I thought it is better to share this question with all of you also. So, the answer of this question is that in semiconductors, out of electrons and holes, electrons has higher mobility. Fine, means they move faster than holes. So, electrons has higher mobility because they need less energy inside semiconductor. Okay. Now, one more question, it is a offer. Today I am going to give you an offer for each question. One more question that can be asked like this, which out of electrons and holes for a semiconductor, which requires less amount of energy. So, the answer should be that this electron requires less amount of energy. Fine. It is like that why the electron required less amount of energy. So, the answer of this particular question I think is beyond the scope of our discussion. Fine, because we are discussing these points for semiconducting materials just for the, you can say, a type of introduction. Otherwise, you know, this semiconducting materials, this integrated IC technology and all these, they are, I mean, they are just like ocean. Fine. So, it was question number 2. Then question number 3 and 4, please do not forget that both these questions are for 2 marks. Okay. Now, what is meant by depletion region in junction diode? I hope the question is visible to all of you. What is meant by depletion region in junction diode? Now, students, if you just watch our videos of this particular chapter, there are 10 videos or so, by repeated process like 3-4 times, you will find that not even a single question from this chapter for your board exam, school exams is like that where you cannot answer. Even you can handle any type of question, because I prepared very carefully the each and every video, fine, for this particular chapter with utmost care that each sentence of my explanation should address the possibility of any type of questions. Fine. So, on this particular concept, that is depletion region in junction diode, very proper explanation already provided to all of you. Fine. But just for the sake of a type of revision or just for sensitivity, once you create semiconductor, I mean extrinsic or intrinsic. So, just by adding trivalent or pentavalent impurities, accordingly you will create p type or n type semiconductor. So, when you combine both, so what will happen? Flow of charge carriers will start from n side, electrons from p side, holes will start moving. So, ultimately if you try to recall with the help of this type of diagram, I explained you that this particular zone where no charge carrier is present, this is something which is defined as the depletion region. Fine. And beyond this, one side p type, another side n type. Also, during the biasing, forward biasing, reverse biasing of a PN diode, I told you that in case of forward biasing, the width of depletion region is reduced, while in case of reverse biasing, the width of depletion region will enhance. That is why it offers enormous amount of resistance, and conduction of PN diode in case of reverse biasing is not possible. Okay. So, this way with the help of a diagram you can write down the answer, and I am not providing very minute details of these questions like diagram, points, explanation, writing, because of the reason somehow, yes, somehow with the help of these questions we are at Misostudy trying to force you that students please go through few times with these videos of this chapter, and then learn these 10 questions, and after that you can start picking any question randomly from any source, and it is a challenge from our side. Fine, you can solve that particular question. Okay. So, this is the question, it is for 2 marks, and here with the help of a simple diagram you have to explain what exactly the meaning of depletion region, and if this question let us say asked in 3 marks, you can also add in case of which combination the width of depletion region is going to enhance. Fine, and the width of depletion region is of the order of few angstrom, please do not forget it. Once again please take a look, this 2 marks, and it is true for this question number 4. Okay. So, again this question is for 2 marks. Distinguish between forward biasing and reverse biasing of PN junction. Now, once again I will mention, in my video where we have explained this formation of PN junction diode and its biasing, I devoted even complete time for explanation of minute details of biasing. Fine, but here I am just giving you some points. Fine. What is forward biasing, what is reverse biasing in case of PN junction, that is something you have to define. So, in this 2 marks question it is like that, forward biasing 1 mark, reverse biasing 2 marks. So, what you should do first, what should be the process of answering? The answer should be forward biasing. Let us say you forget each and everything. So, simply say forward biasing means connect P end means P type semiconducting materials in P end to positive terminal of battery or source, while reverse biasing means connect P type end of the PN junction diode to the negative terminal of the battery. So, once you connect P type with the positive terminal, so what will happen? Width of depletion region will reduced, and this diode will conduct only in forward biasing, because in forward biasing the resistance offered is negligible, resistance offered by this diode, and in reverse biasing the resistance offered is enormous, large. Fine. So, that is why you can say forward biasing means connecting P end of this semiconductor material with the positive terminal of the battery and connecting negative end with the P side of the semiconductor is reverse biasing. Diode conducts only in forward biasing, and this is the best application of PN diode as what? As a rectifier to convert AC into DC. Fine. So, all these things are correlated just like in the fashion of a chain. Then comes question number 5. Before jumping onto questions, it is my request to all of you, please read the instructions, I mean find out which question is for which marks. So, here question 5 and 6 is for 3 marks. Now, what is light emitting diode? Mention 2 important advantages of LEDs over conventional lamps. Students, normally you will not find these type of explanations in various books and in various videos. Here what I did in this particular segment, I devoted one full lecture, basically not one but 2 full lectures. I picked 4-5 type of devices and then LED, solar cell, like that I explained 4-5 devices. Fine. So, what is light emitting diode? That is light emitting diode is a specific type of diode where emission of charge carriers takes place by means of exposing the diode with the sunlight or any other relevant light source. In that video even I mentioned each and every minute detail of this light emitting diode, LED, QED, even I mentioned that, OLED, I explained you positive negative concept, even which is something that not mentioned in books. OLED, QLED, that was QDLED, something like that, quantum concept associated quantized we have here. Fine. So, all these things I explained in my those previous videos. Now, mention some important advantages. So, if you try to recall, I mentioned that cost is one parameter, durability, reliability, or you can say life of these LEDs, cost, life, performance, colors, various type of colors. Nowadays even on traffic signals they are using LEDs. Even in your houses you are not using normal yellow color bulbs or tube lights, but LEDs. Government is even providing subsidy onto the purchasing of these LEDs. Fine. So, light emitting diode importance economically, technically, there are n number of reasons for that. So, try to watch. If I devoted so much time, if I prepared with this much interest of the videos of all these devices, solar cell, light emitting diode and all these. So, you should try to give at least some amount of time to take look of these questions, these concepts, these points. And even I am once again putting this challenge in front of you. Watch my entire videos, I mean of any particular chapter, and then try to pick up the questions from your board exams pattern on that particular chapter. And if you are finding it anyway difficult that on the basis of the explanation which I provided in videos you are unable to answer the question, it is your choice. You can share on our website, there is a doubt clinic type of link. So, you can click that link, you can share your queries, doubts over there within few hours, sometimes even within few minutes. We faculties love to answer your queries. Fine. Then comes question number 6. Now, this question is really a question which requires some sort of effort, but this question is very simple. Fine. So, I will tell you how the truth table of this particular circuit is going to define. Now, first about these type of questions, what should be your first approach? Start giving the numbers to the various logic gates, and also first you have to identify which one is which gate. Say for example, over here in this particular question, this is AND gate. AND gate means multiplication. This is OR gate. OR gate means addition. Okay. So, let us say this is logic gate number 1, this is logic gate number 2, no problem. This is the process, this is the method of answering these questions. Please learn like this. Fine, you cannot remember, you cannot prepare, you have to take the look of the diagram, only then you will have to apply the logic. Okay. Now, over here if I am saying this is output y prime, fine, and if it is B, it is A, please take a look. So, what I will write down over here? I will write down A dot B because it is AND gate. Now, take a look over here, basically this y is the final output, fine, and this y if the final output, then please students take a look, that is B, and this entire amount is going, fine. So, this y prime is going here and this A individually coming over here. So, about y, what I can say? About y I can say y prime plus A. Y is equal to, y prime means A dot B, this is the meaning of y prime, fine, plus A. So, I can write it down as A y prime, sorry, okay, no problem, if we write it like this, no issues, A dot B. Write it this way or this way, it is not going to create any type of impact. Now, this is the arrangement of expressions on the basis of Boolean algebra. But then you will say, sir, where is the table, that input output truth table? Fine. So, what I hope this particular aspect is clear to all of you. So, my request is, if I am erasing it out, I hope you will not mind it. Fine. Then let us try to create a table, so that I can show you various types of outcomes. Fine. What is the table? It is like this one and this one. Fine. So, let's make the table proper. Now, I want to use a red color chalk to mention some values A, B, okay. Then A dot B, this y prime, and then this y. Fine. So, A B input is going over here, and then according to these values. So, A B means 0 0 possibility. I will use different color to show you. 1 0, then I will use again a different color, that is 0 1. Let us make it also separate like this, and then 1 1. These are the values mentioned for A and B. Now, it is what? It is your dot, and so low low low, high low low, low high low, and high high high. Fine. Similarly, over here low, so it is going to be low, then low, then for this one it is going to be y prime plus A is equal to high, then it is again low, and it is high. So, this is the aspect with which you can say truth table and the Boolean expression. So, these type of questions are not difficult, they simply ask some amount of efforts from your side, that is it. Okay. So, I hope you all will find this entire explanation is simple and interesting enough for understanding this topic. Now, this 1 and 2, then comes question number 7. Now, there is a specific purpose of selecting this question. I will tell you what. First thing is 5 marks. So, 7, 8, 9, 10, 4 questions for 5 marks. Now, students, in examination hall, whatever the answer you write down, normally after coming out from the examination hall, the general expression of any student is like that, oh, I provided the answer of all these theoretical questions, very good. But after declaration of the result, you find, oh my God, my marks are not up to that much expectation. So, where is the problem? So, with the help of this particular type of questions, I would like to tell you certain difficulties that any student may face while providing the answer of pure theoretical questions. So, let us take a look over here, that is intrinsic and extrinsic semiconductor. Now, suppose you are supposed to write down what is intrinsic and what is extrinsic semiconductor. Fine. I think for the time being, let us try to move away from the question. So, you have intrinsic or pure semiconductor. Let us say you want to conductor. Let us say you want to provide the answer of this particular point, forget about 5 marks. Suppose you want to write down something for this one liner. So, your answer should be the in nature whatever we are getting as semiconductors like silicon, like germanium, fine. They all are pure intrinsic semiconductors. They have the conductivity more than insulators and very less than these what that is defined as these conductors. So, there is no impurity, and then you should also mention that for example, silicon, germanium and so on. Now, after that extrinsic, fine. So, extrinsic as the name itself suggests, okay, added some impurity. Why? I want better conductivity of semiconducting materials, okay. What type of impurities? I want to add two types of impurities. One is trivalent. Trivalent means lesser the electrons, and you know 4 bonds are there in a semiconductor. So, one hole is available, so it is p type. And if I am adding these electrons larger in number, so what will happen? It should be pentavalent. Pentavalent means 5 electrons. So, 4 are going to be associated with the 4 valencies of the atom, whether silicon or germanium, but one remaining electron will random motion. So, both these methods means adding either trivalent or pentavalent impurities, but after the creation of p-n junction, p type and n type semiconducting material, the conductivity is going to be more, and this is extrinsic type of semiconductor where some foreign element is there. Then comes n type and p type. I explained you, fine. By adding the impurities you can create this n type, p type. Now, discuss common emitter amplifier using NPN transistor. For this question, once again I would like to say that in my videos I very categorically mentioned that there are 3 combinations possible: common base, common collector, common emitter. Common collector because gain is nearly equal to unity, so no one love to consider it. For this common base combination, whether NPN or PNP transistor, by using this way you can say the gain is less than unity, negative. So, it is negative feedback circuit, and this is like third one is this common emitter amplifier. Phase change of the input output will take place over here, maximum used, and here the gain is very large. So, here one thing you should do, first you should draw the diagram, and after the diagram you should take care of writings, fine. But say for example, for this particular question, please practice which one is NPN, which one is PNP, which one is common base, which is in common emitter, because common collector not used, fine. So, over here it is E, it is C, it is B, it is B, like this. Then this is RB, then you have one capacitor, name of this capacitor is let us say C1, then over here it is input, fine. And from here you can say one source is also connected like this, fine. And then keep on moving over here, then you have to connect a load resistance RL, then there is like this, add it, and after this what exactly required, that is one more capacitor, let us say C2, and here it is going to be output. Now, shape of the input output is also important. So, for input you have to show it is like this, and for output the output is like this. So, you can say reverse phase. Input, I am not hiding anything, this is input, this is output, fine, and this is, I should not write down like this, input. Fine. So, this is the scenario for question number 8. This way you can answer it. Then comes question number 9. Discuss how the OR gate is realized from the NAND gate. Students, in my regular videos I provided many examples with explanation of how you can convert any gate in type of another gate. So, for example, if you want to convert OR gate is into NAND gate, the circuit diagram is simple. It should be like this. Both inputs are same way. So, that is say for example A. Similarly, second one this way, okay, that is B. So, now let us say this is 1, this is 2, fine, and the output that you are getting over here is input in another. So, this is the way of arranging and then you can get the output. So, here you will get A bar, here you will get B bar and some of the A bar B bar over there. Let us say this is Y1, this is Y2. So, Y is going to be what? Y1 dot Y2 bar, and then you can provide the answer. This way you can find the solution of these type of logic gate questions. These are very simple provided you have better practice. And then students, finally we are reaching to the last destination of today's discussion, that is you have to for the 5 marks you have to explain what is NAND gate, what is NOR gate, what is exclusive OR gate. Once again the same logic. I devoted very good amount of time and one complete video about combination of AND and OR gate, because you have these 3 basic gates AND, OR and NOT. Rest are combinations. Say for example NAND, NOT plus AND, NOR, NOT plus OR, it is exclusive OR. Say for example exclusive OR, I want to explain the truth table. So, exclusive OR means wherever only the values are low high, high low, only that. So, 0 0 not of our interest, 1 1 not of our interest, for us either 0 1 or 1 0, that will give me high high. So, this is for exclusive OR gate. So, watch that video, make yourself strong, revise and then start answering these questions. So, now I think we should stop over here. Fine, very soon I will come back with some new videos. Obviously, it is in continuation process, but till then take care of yourself, and finally thanks a lot for watching this video.